One of the most rewarding yet scariest positions that developers choose to go into is backend development. As a full stack developer, backend development does seem a little bit scary. The classic stereotype amongst devs is that front-end developer will either look like a hipster or some super aesthetic genius, while the backend developers are stuck looking at a green screen and black terminal in the closet. I will not confirm nor deny this. Being a backend developer is one of the most critical roles in the whole entire tech stack. Imagine being able to click on a fancy button just for it to do nothing. Sort of like a closed door button on an elevator. You get to work with incredible tools, always learning new things, and what else? Oh, a hefty paycheck? This was my personal roadmap, but I took inspiration from roadmap.sh. So I'll include a link in the description if you want an even more detailed roadmap than what I have here. With all that said, let's get into the Backend Developer Roadmap. General purpose programming language. Now, if you want to be a backend developer, you have to get comfortable with at least one programming language of some sort. A lot of people will do one tutorial on a language and bail halfway through and start a new one. This is your sign to pick a programming language and stick with it. No matter which one you choose, you'll be more productive sticking through with it than changing for the 12th time. You won't be wrong if you choose any of the following: Python, JavaScript, Java, C#, PHP, Rust. I would highly recommend reading a book related to the programming language that you choose. This will help you understand the basics on how to program and what it takes to become a programmer. And to truly soak this all in, push yourself to not constantly do tutorials. Tutorials are great for a quick reference, but constantly watching tutorials over and over and over again hinders your ability of being a practical dev. When a mother bird pushes their child out of the nest, she expects them to fly. That's what I'm doing to you. Fly, my little programmer. Is this scientifically accurate? One of my favorite resources for new developers is Projects by Karan on GitHub. It gives you ideas as a beginner programmer to work on in order to improve your skills. Work through a small amount of projects until you really start to get the idea. Don't forget, all programmers use Google, and the ones that say they don't are liars. Once you understand how a programming language works, you are ready for the next step. Internet and Linux OS. So the internet is when you can type a message to your friend and listen, everyone and their grandma knows what the internet is, but do you truly know what the internet is? The next step on this roadmap is learning Linux and how the internet works. Why Linux? Well, it runs on about 96% of all servers around the world. So I would say it's a safe bet. Of course, choosing what distribution of Linux is something you have to think of as well. My recommendation if you're new is to stick with Ubuntu, as it's the most popular and versatile for people just getting their feet wet. If you're an experienced Linux user, well, you've already told me that you use Arch, so don't worry. The important part about this step is getting comfortable with the command line. The bad news is that learning the command line is a lifelong journey, but the good news is that you'll look like a total badass. When learning Linux, you'll need to learn about how the OS works with all of its subdirectories, input-output management, threads, terminal commands, and a lot more. One of my favorite books on this subject is Linux for Beginners by Jason Cannon. It's good for teaching you the basics and beyond. Depending on what kind of software you want to run on your servers, you'll need to learn those as well. Something like Nginx or Apache for web servers, which circles back to the internet. Understanding the different protocols that are made to communicate between a server and a client is very important. DNS is a concept I learned way too late. I never understood why, when I type lewismenelaws.com, very cool website by the way, would it know to go to my website. Learning HTTP, IP addresses, domains, and other basic internet protocols is an absolute must. Otherwise, you'll rip your hair out trying to debug it later. Databases. The bread and butter for most tech businesses is that sweet, sweet honey known as data. But where do we store this data? If only there was a place we can store. You get it, databases. The word database is such a broad term used to express a store of data. You've probably heard your boss tell you to examine their exquisite database just to open up an Excel spreadsheet with like 15 rows in it. Databases are no joke. Some backend developers specialize only in the database. That's how critical it is to organizations. There are two categories of databases that are most common in the industry right now: relational databases and NoSQL databases. If I were you, I would only learn one, and that would be relational databases. Relational databases include PostgreSQL, MySQL, MariaDB, and Oracle. What makes a database over just pouring your heart and soul into Excel is the relationship. Think of it like this. If I had a pet store that I wanted to record every customer and their pets with an Excel file, I would have to create a column called Pet 1, Pet 2, etc. So when Stacy the crazy cat lady comes in with her 30 cats, you can see how this doesn't work at all at scale. Databases use a language called SQL to help you query from database tables. So you can capture all the customers at your pet store and all of their pets in one single query without cluttering anything. So yeah, SQL is another language you should learn. NoSQL doesn't use SQL. Get it? NoSQL. You see where they're coming from here? NoSQL databases uses a key value store instead of a column row type. You don't get the relationships, but if your application requires high performance and unstructured data, this honestly might just be a great solution for you. Databases is a massive concept. Trust me, it's pretty dense. But choose a database and learn SQL, you should be good. My favorite place to go is postgrestutorials.com. It gives a great insight to SQL and the features that PostgreSQL have. Language-specific frameworks. Now, when you're at this stage, you'll know a lot about servers, programming language, and databases. So to simplify a lot of this for you, learn a language-specific framework. Do your own research on what you think you'll be more comfortable with, but you'll most likely find each language has two categories of web frameworks: batteries included and non-batteries included. Batteries included will include many ways to streamline the development process by managing the HTTP request objects, migration of databases, querying the database using a simpler language, caching, and much more. Now you're probably wondering why I didn't recommend this after the programming language. I'm a huge believer of knowing what the problem is before you find out or know about the solution. When you're using a high-level web framework, it's great for that developer efficiency, but you might have to go under the hood sometimes, so it's important to have that knowledge. These batteries include frameworks would be things like Django, Laravel, Rails, Meteor. Non-battery included frameworks strips all this away and just gives you the bare minimum, usually just the request response web server functionalities. If you want more control of what packages you want to have in your project or just have a more slim application, I would highly recommend these types of frameworks. These include frameworks like Express, Flask, or Sinatra. You really can't go wrong with either type of framework. Similar to what I said in the programming section, just stick with it. Trust me, you'll thank me later. APIs. More specifically, REST APIs. REST APIs are a very important way for you to have clients communicate with your server. If you are building a web and mobile application, you wouldn't want to develop two separate interfaces to talk to your server. Therefore, REST APIs are a great way for you to code an interface for all of your clients. There's many ways to implement a REST API. The most common one you'll see in application now is using JSON. However, you still might have some psychotic devs using SOAP APIs. And trust me, SOAP is not clean. The doctor said the medication wouldn't kick in for a couple weeks. RESTful APIs mixed with HTTP is a very reliable way for you to integrate authentication into your app, using things like JWTs, OAuth, or another form of token authentication. APIs also introduce another problem amongst cross-platform development, serializing data across separate platforms. The good news is that there's a lot of packages that will help you with this. One of my favorite packages is an add-on to the Django framework called Django REST Framework. In fact, most frameworks come with some sort of built-in or heavily supported package that can easily turn your code into REST frameworks with minor configuration. I would then learn what's the easiest way to develop a REST API with your current application or programming language. I also love looking at existing applications like the Stripe API for inspiration on how to design my API to be as easy and professional as possible. Containers and virtualization. Story time. I heard so much about containers when I was first a developer, but I just thought, who cares? I'm not going to bother with this.
Nope.
I don't need Docker. It works on my machine, so we should be good. Famous last words. This really bit me in the ass when someone on a Windows machine couldn't download the dependencies correctly. So, containers. What is it? Docker packages an application and all of its dependencies in a virtual machine that can run on any machine. So let's say I have a Node.js application that requires Express and a MongoDB. Rather than having this complicated setup where I install the MongoDB client on my Mac and run a certain version of Node, I can have it isolated in a virtual machine that will always work the same as always. Docker is one of those softwares you will only know its value when you shoot yourself in the foot by not using it. It's important to learn Docker at a later stage of your development journey because when you start developing with Docker, it expects a knowledge of all the applications you use. Since you've already learned Linux previously, you'll already know how to expose ports, use the command line, and much more. If you decide to go into something with a container-like infrastructure, eventually you'll want to learn how to deploy those containers with an orchestration service like Kubernetes, but that's up to you at a later stage. Cloud services. Cloud services is a very complex topic. Not because the concepts are hard necessarily, but the amount of services they provide is just, it makes my head hurt. One of my favorite videos by Fireship explains the top 50 AWS services in 11 minutes. But that's just one cloud provider. A lot of people try and jump into AWS thinking that this is where the money is, but it's important to learn this step last because most of these cloud services are there to convenience you at a later stage. Think of it like this. All the stages I mentioned previously have a huge amount of roadblocks, like scaling your database, provisioning your server, launching Docker containers, deploying an API, and more. Oh, and there's a lot more. Cloud providers provide their value by offering these services, but at a cost. Think about how much it would cost to build servers, server racks, all the cords, a building to put all this in, having this in multiple regions. Big money. Cloud providers innovate by doing this hard work for you and then just charging you by the usage you use on the machines. Think of it like renting a server. When you're at this stage, you should investigate architectural patterns that your application will need to run your operation. There are lots of different options like monolithic apps, serverless, or microservices. Although it's way above the scope of what you should learn, one of my favorite talks is by Josh Evans. He talks about Netflix's approach to microservice and it's just brilliant. I can't emphasize enough why you should learn this step last. As a developer, your needs will be different from mine, so companies like Azure, AWS, or Google Cloud will provide solutions and different things for your needs. That being said, you'll still need to know how they work through their documentation. When it comes to a provider, they don't really differ at all, some offering more generous free tiers than the other. The best resources to learn all this is usually from the source itself. The documentation for Azure, AWS, and Google Cloud are all fantastic. Keep learning. Backend development is such a huge field because of all the problems that come up from the solutions we create. Implementing search, testing, caching, version control, eventually DevOps. The amount of things to learn as a backend developer is overwhelming. I see you sweating behind that screen. It's okay, sit down, drink a glass of water, maybe make yourself a grilled cheese sandwich. If there is one thing you can take away from this roadmap is to figure out what position you're in right now and figure out your next step of action. If you want to become a developer, you'll have to understand that you're going to make something really crappy at first and fail so hard. Trust me, I get very embarrassed at my old projects. But that feeling of, oh, I finally get it, is an addictive feeling that you need to make yourself earn. So Google and watch YouTube tutorials all you want, but truly be the bird that mother bird sent off to fly or die. Did anyone look up if that was real yet? 2022 is already a crazy year and lots have changed. But that's the incredible thing about technology. Things just change so fast. What other roadmap would you like to see? Let me know in the comments. Subscribe if you want to see more dev tips, and thank you so much for 20,000 subscribers. I can't even, on my last video, I hit 10,000 and that just seriously blows my mind. I can't thank every single one of you. The comments have just been so incredibly inspiring to me. It feels so good to help other developers. Thanks for watching. I hope to see you in my next video.